You walk into a room. On a table in front of you are two boxes. One is completely transparent, and sitting inside is a stack of cash totaling exactly $1,000. The other is a solid mystery box. You can't see what's inside. You're not alone. Running the game is a supercomputer with a terrifyingly accurate track record of predicting human behavior. It has analyzed thousands of people before you, and it almost never makes a mistake. Here is exactly how the game works. The computer gives you two choices: take both boxes or just take the mystery box. But before you even walked in, it made a prediction about what you would do. If it predicted you take both boxes, it left the mystery box completely empty. But if it predicted you would leave the $1,000 and only take the mystery box, it put $1 million inside. You have to remember, the prediction is already locked in. The computer made its guess and filled the boxes before you even learned the rules. The money is either sitting in that mystery box right now or it isn't. So what do you do? Do you take both boxes or just the mystery box? This is Newcomb's paradox. Whatever your gut is telling you right now, your answer is about to place you on one side of a fierce debate that splits some of the smartest people on Earth right down the middle. This chart shows the results of massive polls of both general audiences and academic philosophers. When presented with this exact problem, people divide almost exactly down the middle. Roughly half become die-hard one-boxers, and the other half become equally passionate two-boxers. The reason for this split is that the game is a trap. It pits two perfectly sound frameworks of human logic against each other, forcing them into a complete contradiction. Let's start with the two-boxers. Their entire argument rests on a simple physical reality. Whatever choice you make right now cannot reach back in time and change the past. This visual maps out a concept called causal decision theory. Because the computer already set up the game, the mystery box currently contains either $0 or $1 million. Your thoughts in this room do not alter reality. Looking at the matrix, if the mystery box is empty, taking both boxes gets you $1,000 instead of 0. If the mystery box holds the million, taking both boxes gets you $1,001,000. No matter what the computer did yesterday, you are always $1,000 richer today if you grab everything on the table. In game theory, this is known as a dominant strategy. If you follow strict cause and effect reasoning, leaving free money behind makes absolutely no sense. But the one-boxers look at that logic and laugh, because it ignores the most important piece of evidence in the room, the computer's flawless track record. This camp relies on evidential decision theory. This equation compares the expected utility of your choices. Expected utility is just the potential payout multiplied by the probability of it actually happening. Because the supercomputer is incredibly accurate, the probability that it correctly predicted your choice is near 100%. If you try to outsmart the system and take both boxes, the computer almost certainly saw it coming and left the mystery box empty, leaving you with just $1,000. But if you take only the mystery box, the computer likely predicted that too, netting you the million. The guaranteed $1,000 is mathematically irrelevant when weighed against a near statistical certainty of becoming a millionaire. To a one-boxer, following the math is the only sane choice. The two-boxer has unassailable cause and effect logic. But look at what actually happens in practice. Almost everyone who takes one box walks out of the room a millionaire. Everyone who takes two walks out poor. This creates an incredibly annoying stalemate for philosophers. The one-boxers can look the two-boxers directly in the eye and ask a very simple question. If you're so smart, why aren't you rich? That is the core trap of Newcomb's paradox. It reveals a crack in human decision-making, where acting completely rationally according to cause and effect actually guarantees the worst possible outcome. Beating the supercomputer requires a strategy called pre-commitment. You have to influence the prediction before it is ever made. You must wire yourself to be a genuine one-boxer, creating a personality so predictable that the computer sees it coming. When the machine analyzes you, it detects a conviction so strong that it has no choice but to place the million in the box. We see this dynamic in the game of chicken. When two cars speed toward each other, the winning move is to visibly rip the steering wheel off and throw it out the window. By destroying your own ability to swerve, you force your opponent to handle the burden of avoiding a collision. Intentionally removing your own options gives you power over their behavior. This logic of pre-commitment underpinned the strategy used to prevent nuclear war during the 20th century. During the Cold War, the United States and the Soviet Union reached a terrifying military stalemate. By the mid-1960s, the U.S. stockpiled over 30,000 nuclear warheads. Any direct attack from either side ensured a counterstrike that would devastate both nations. U.S. Secretary of Defense Robert McNamara championed the strategy of mutually assured destruction. He argued that survival depended not on disarmament, but on a highly reliable ability to retaliate. Mutually assured destruction required an unbreakable pre-commitment. Both sides had to believe that a launch by one would trigger an automatic, world-ending response from the other. The irrational act of committing to global suicide was the exact mechanism that maintained the peace. By removing the option to back down, the superpowers made an attack thinkable for neither. The Cold War and the Newcomb puzzle reveal the same underlying truth about human behavior. Rationality is often viewed as a series of isolated, calculated choices made in a vacuum, but this framework fails when you are being predicted by others. Long-term success often depends on wiring yourself to stick to a set of commitments, even when they seem to limit your options in the moment. By becoming the kind of person who honors their rules, you change the world's prediction of you, and you walk away with the $1 million. If you've made it this far, thanks for watching. Please consider subscribing to Deep Dive Daily, hitting that like button, and dropping a comment below.